unit. Next week, Thursday. Huh? The next quiz is 3.6 through 3.8, and it's on Tuesday. We'll see how I feel about that. You just were.
Oh, that was that. Huh? Oh.
3.2 or 3.3 through 3.5. Okay. Okay.
I thought it was third question. I think was.
It depends on your form. Some of the forms you could have just done the. Huh? Yeah. It was normal.
Miss Russell, if I just treat it as a normal geometric and didn't like compare,
Then you probably did something wrong.
yeah, but how much points would I get off?
Many. All right, so ratio test. The ratio test is pretty useful if you have, we want to use when we have a factorial. Something like n or n plus 1 factorial. Some kind of exponential. And where it's exponential mixed in with other stuff so that it's not geometric. So like, especially factorials that are not in the numerator, then you'd want to do the ratio test. Exponentials, like if we're looking at 1b, on 1b, the exponentials are mixed in with the n squared, and while you might think you can compare it with 2/3 to the n squared there kind of makes me like a little nervous if that's changing too much about it. So I would probably just do the ratio test for b because I'd be worried that I'm not really comparing something like true to its nature. So we got factorials, exponentials, and also in 3b, we're going to use a ratio test to find what's called the interval of convergence. Which we don't have to worry about yet, but it's just another time where you're going to be using the ratio test. Just so you know, a lot of the time these series tests are multiple choice questions. So unless it like has specific rules, like it's saying, does this satisfy, which of the following three, usually they'll do 3 series, satisfies the integral test, or something like that, you can use whatever test you want to use. Occasionally there's a series test like as like part A of one of the free response questions, but the main thing on free response questions is the second part of this unit, and the second part of this unit is like always a free response question every single year. Last year it was 2 free response questions, so that was so fun for them. Okay, so ratio test is pretty easy. You just take the limit of n plus 1 divided by the original series, where that limit, if that limit is less than 1, then it's converging. And if that limit of an plus 1 is bigger than 1, or obviously infinity is bigger than 1, then it's diverging. Sometimes, though, the ratio test is inconclusive when this ratio, the limit of the ratio, is equal to 1. So be careful. It's not less than or equals to. Anytime you get like both same here, then, and it's not like 3/2 or something like that, then it's inconclusive and you gotta use a different test. All right, so doing the ratio test. We take the limit. It's absolute value too, by the way. I'm plugging in, we're doing limit an plus 1 over an. Everywhere that there's an n, I'm putting plus 1, n plus 1. And I could divide by the original thing. When I divide by this, what am I actually going to end up doing every time? Multiply by the reciprocal. Oops, I forgot my factorial. Questions on what I've written so far? Okay, now we can simplify it. So simplifying these, make sure you realize if you have 2 to the n plus 1 over 2 to the n, that's the same thing as 2 to the n times 2 to the 1 over 2 to the n. And since everything is multiplying, you can cancel across the fraction bar. And you're left with 2 to the 1 in the numerator. And then in the denominator, you'd be left with n plus 1 because the factorials are going to cancel each other out. So let's go over how those factorials cancel each other out. All right, n factorial is n times n minus 1 times n minus 2, etc., all the way down to 3 times 2 times 1. And then n plus 1 factorial would be n plus 1. What's 1 less than n plus 1? N, and then n minus 1, n minus 2. So you're probably going to get good at canceling out factorials and realizing that you could have just like canceled them like this from the jump, and like as long as you notice those patterns. But that's why they cancel out to being 1 over n plus 1. Also, the more common thing, like if you look up a video or something, most of the time you're going to see someone reduce it like this. Instead of like doing the full expansion. But either way, whatever. As long as you realize that you're just going to be left with a n plus 1 as a denominator. Okay, so once we have simplified across the fraction bar, now we're evaluating the limit. What does this equal? 0, which is less than 1. Because the limit is less than 1, then we would say that the series converges by ratio test. Try to do B. Select all of preference. Right, nothing else can cancel. These n squares can't cancel each other out because I'm not like gonna plop the square into the parentheses where there's a plus or a minus sign. So we're just leaving it like this. Is this big bottom, big top, or both same? Both same. So then what does it equal? 2/3, which is smaller than 1. So it converges by ratio test. Try to do D by ratio test. D as in donut. Okay, so in this one, does anything cancel out other than like the negative ones? No. And do you even think that the negative ones really matter if it's being absolute valued? No. So like if you see a -1, you can kind of like ignore it. It's pretty irrelevant since it's being absolute valued. But nothing's canceling really. But what's the degree of the numerator? 3/2. What's the degree of the denominator? 3/2. So what would, we have a both same and the coefficients are all 1. This is inconclusive. You could leave it up. It's okay.
Oh, sorry.
Now, what test do you think you would use? You could use, but no, limit comparison, you can't have it be negative, so you can't use limit. I think you would use alternating series. It didn't ask you, but just eyeballing it, I think the limit would be 0. And that it's decreasing. So I think that it's converging by alternating series test. But it didn't ask you to do that. It asked you to just use the ratio test. Sadie, did you have a question?
Oh, I was wondering how you decided that it should be 3/2.
Oh, because if like, not that you would FOIL this out because it's like a 1/2, but like you have like a n to the 1/2-ish here. And then you have an n to the 1 and you're adding their exponents. So 1/2 plus 2/2 is 3/2. Mm-hmm. Okay, I was going to skip this one, but I think you guys are so smart that we'll do it. We're capable. And I want you to see kind of a messier situation. Okay, this simplifies. The factorial is going to cancel out and leave you with an n plus 1 factorial on the bottom. Or just an n plus 1, I'm sorry. Okay. And then n to the n, not going to reduce. Could you, though, reduce the n plus 1 to the n plus 1 over n plus 1 to the 1? Yeah. So then you'd be left with n plus 1 to the n over n to the n. Wow. So fun. And then I would rewrite this to look like n plus 1 over n all to the n. And fun fact, this is the definition of E. So this is equals E, yay, which is bigger than 1, so diverges by ratio test. I don't expect you to know this one. This is one that I would do the root test with. Huh? Yeah, but E came from this limit of n plus 1 over n to the n. As like the natural base.
How is this for logs?
Huh?
So how is this used for logs?
They have like an inverse relationship. Okay, also, fun fact, n to the n is bigger than n factorial, so you could have done the nth test term for divergence on this one. But I just wanted you to see this super fun little definition of E. No. No. Okay, so on the AP exam, the root test is not explicitly covered, but in situations like this, when an exponent is n, you might want to know that the root test exists. A lot of my students have found that they like the root test better than the ratio test anyways, because if you're raising something to like the 1 over infinity, then it's like much easier to tell what's going on because it's like raising it to the 0 power. So the root test, I'm not exactly sure why College Board doesn't include this one. I think it's a very quick and easy test to do. The root test is basically taking the series and raise a n to the 1 over n. It has it as a nth root in like the definition, but you're really just taking the series and raising it to the 1 over n and then doing the limit. So in this, same rules as the ratio test. Meaning, if the limit is less than 1, we're converging, diverging if the limit's bigger than 1, and inconclusive if it equals 1. So like I would have used the ratio test. But it would have been inconclusive. Well, I would have used actually the nth term test for divergence way back here on this one. Because n to the n is greater than n factorial. So it would have been big top. Yes.
And factorial is bigger than like the number to the n, right?
Yes, so this is bigger than like a to the n. But n to the n, like infinity to the infinity, is technically an indeterminate form, but like that's really effing big. You know, like 100 to the 100th power is big versus like 100 times 99. That's also really big, but like n to the n is bigger than n factorial. Okay, one little quick, easy, do the root test. How do you think you might want to rewrite e to the 2n over n to the n so that raising it to the 1 over n is a little easy? Zeppelin? Good. Okay, so that's what this thing is essentially equal to. That's an. And let's take the limit. And raise it to the 1 over n. It's technically absolute value just in case it's like an alternating series, so you make sure that's positive. Okay, the n's cancel out in the exponent. So you have the limit as n goes to infinity of e squared over n. Big bottom, big top are both same. Big bottom, so this equals 0, which is less than 1. Ratio and root test, both when they're less than 1, converge. I know, I really have never known why they leave the root test out. I'm like, it's just like so fast. I don't know. But, yep. And you are allowed, so someone asked this in second period, I thought it was a really good question. If for some reason you are doing a test on like a free response question, like a series test, and you do use the root test, that is a real test. It's not like a fake thing that I'm making up. It's just not one that College Board is going to put on like the multiple choice. They're not going to say like using the root test determine convergence or whatever. So you are allowed to use this if you were to need to do it on a free response question. You just don't have it on multiple choice is basically the moral of that story. All right, so we've done all the tests. Yippee, we made it. Now let's go through. Let's look at some quick ways to tell what test we need. So basically, if you have big top or both same, use the nth term test for divergence. If it's a special type, geometric, P-series, probably not going to worry too much more about telescoping, or alternating series, do those specific tests. Sometimes the best test to use is unfortunately the integral test, like on number 2. Anytime you see an ln, you should be integrating, especially ln with like a n in the denominator, you should integrate that because the u sub would be easy and cancel out that n that's in the denominator. And then bada bing, bada boom, pretty easy integration from there. So just like in unit 2, when I said, make sure you always check for u sub first, in this unit, you always want to check for n-term test for divergence first. So do that first. I think number 1 was n-term test for divergence. And on certain forms, also number 3, you could have done the n-term test for divergence. Kind of messed it up on that one. Didn't mean for that to happen. Meant number 3 to be a limit comparison test. But oh well. And then comparison test. Okay, so go through with your group. I want you to spot check A through G, determine which test. First, just determine which test you would probably use. And then if you have time, try to figure out if it's converging or diverging. Explain to each other why you're using certain tests.
Moving on. Nth term.
Yeah, if the limit level to infinity is not equal to 0, then
I guess that'll be the one that gets wrong.
Stop it. I need that.
This is quant mathematician.
Yeah, I was all because I was putting it in the first place. Yeah, this is going from like
I don't really care anymore. No. Are you sure? I don't know.
Did you feel like, did you raise it, like, inverse it?
No, you can run into the slope from it. Like the derivative.
I also.
And so I'm saying like the derivative is getting, I was like, ratio is 1/u. So I was like, okay, that's fine. So the slope is going from like plus 4 to 1. So it's like the slope is still getting, and I thought it was happening here, but apparently it's happening. You'll see that. But I did use it.
And I also did the
This one.
No, coverage is third, right? It's a both thing.
Except for.
Does A converge?
Who?
Does A converge?
That
No.
Because yeah, since 1 group is not equal to 0. Therefore, that
This Russell, your pass is stuck to a spider. Do I take the entire spider? Okay. I feel really festive right now.
Maybe click it a little higher.
There's a spider now?
Yeah, spooky. All right, so on A, what test? End term, and what would it be real fast? Obviously, it has to be diverging if you're using end term. How about B? Geometric, and what would it be? Converging or diverging? Converging, because R is less than 1. Oops, I don't know what I was doing with fraction there. Okay, then C. Integral test. Let's do it just for the funsies. Yes. Integral test. Integral test. So we got, is it positive? Yes. Is it decreasing? Yeah, that denominator is very big. Is it continuous? Yes. So integral test. Whenever you see an E having some crazy exponent, that's probably going to be U. So let's make U be negative n squared. Du is negative 2n dn. And your n's are going to cancel. Here's another thing that I've noticed you guys doing a lot lately. Once you've done the U sub, often I have noticed, it would never be you, but like a classmate of yours or your peer, right now is plugging you back in and then be like, how do I integrate this? Silly gooses. The entire point of U sub was because it was hard to integrate. So that's why you did the U sub. You need to actually integrate it and then plug U back in. So when we integrate this, we're going to get negative E to the U plus C. But we know our boundaries are really from like 1 to infinity. So let's change that to be like a B and do limit B going to infinity. Okay, so then we got limit B going to infinity, negative 1/2 E to the negative B squared plus 1/2 e to the -1. When we evaluate at infinity, what's e to the negative infinity going to be? 0. It doesn't matter what this integral equals. It's just the fact that this equals a finite number that the integral converges. And since the integral converges, what does the series do? The series converges as well. Okay, D, what test would you use? Comparison. Could you do direct comparison? I'm comparing with 1/3n, which diverges by p series, right? And then direct comparison, so it's diverging 1/3n plus 1, that would be bigger, so this is all smaller. And then this one is larger, that diverges, is not able to do direct comparison.
1/3n is
Yeah, because you're going to take the 1/3 out.
And then it's just n to the 1.
But
1 over n.
wouldn't that?
It's as long as it's not adding to the p. So we're probably not going to use the direct comparison because it's larger, that diverges. Just remember with the limit comparison, we're going to do the original thing divided by the thing we compared it to.
I would like the spider.
And this is 1, which is positive and finite. So this would diverge by the limit comparison test. So question on the quiz, if you said you were using the limit comparison test and you don't have anything written about a limit, do you think you're going to get the points for using the limit comparison test? No, cries and oops, I forgot to actually finish doing the test I was supposed to be doing. We need to actually do a limit if we're using the limit comparison test. Okay, on E, we are not using a comparison test. Why are we not using a comparison test? It's alternating. Comparison test cannot be used when a series is negative. It has to be positive. So what are we using instead? Alternating series test. And let's check real quick. Would the limit equal 0? And is it decreasing? Heck yeah, it is. So make sure also we're plugging in n plus 1. The comparison is not for n plus 2. It's for n plus 5, which is smaller. So converges by alternating series test. Or rapid firing here. All right, then we look at F, and we see a factorial, but, so we could do ratio test. I think ratio test is inconclusive. If we do, what else, other tests would we use? Nth term, because it's big top. N factorial is greater than 10 to the n. So when you do the nth term, you're going to get infinity, which is not 0. Huh? Oh, maybe ratio test works. I don't know. I just did nth term. I was thinking they were like the same. Oh, wait, no, because then it would be bigger on the bottom. No, it would be bigger on the top when you flip it. Yeah, because you'd have n plus 1 over 10, which would be a big top. So if you did the ratio test, you'd end up with n plus 1 over 10, which is greater than 1. So diverging by ratio test. Okay, what test do you think you'll do on G? Root test. Root test. Limit. I feel like I'm writing so fast that my hand is starting to hurt. My poor hand. Wah. I'm about to. We're almost done. This is 1/2, which is smaller than 1, which is converging by root test. Okay, we did it. Congratulations, you've made it. Oh, I want to do the chart.
Are you gonna post the chart when you're done?
don't think so. Okay, so converging is the first column. So if it's less than 1, it converges. Diverges is the second column. And then remember, if you get it equal to 1, it's inconclusive.
Wait.
Should it be greater than?
Yeah, shouldn't it be greater than 1?
Yeah, my bad. I was just making sure you're paying attention. Okay, on the class, where I think you're still writing this. Let me chill for a second. We're doing 1, 2, 8, 10, 14. 1, 2, 8, 10, 14. Now on number 1, you have n factorial, it's big top. Yes, n-term test for divergence would have worked, but it says use the ratio test. So sorry, you have to use the ratio test. You're gonna be okay. Should I put on spooky music? 1, 2, 8, 10,
David's.
and 14.
These both have the same rules. We do different things, so that's just like whether the greater than less than and the one is like has the same outcome. But this is the test.
Well, they won't ask you to use it in a multiple choice, but you can use it.
Yeah.